Hello everyone, welcome back to my presentation. In this lecture series, I am discussing about DC circuit mathematics only. In the previous section, I discussed about some problems. You can check out the previous video. Now let's start it our new video, and this is the second video for DC circuit. So these are the outlines of my presentation, and you can note down here. And all the problems are from fourth edition of Alexander and Sadiku. Okay. So let's go to the problem number 1, and that is example 1.4. So from this example 1.4, you can see that the question asked us an energy source forces a constant current of 2 ampere, and I can write down here current I is equal to 2 ampere for 10 seconds to flow. So time is 10 seconds throughout a light bulb. So if I draw something, we have some energy source here and it directly connected to some light bulb, and this energy source having the constant current of 2 ampere. Current is constant 2 ampere, and this current flows to this bulb for 10 seconds. If 2.3 kilojoule is given off in the form of light, so in this light electrical energy is converted to light energy, and this energy is represented by 2.3 kilojoule, and this is the energy. We can write down this as W. 2.3 kilojoule, that means 2.3 into 10 to the power 3 joule. Calculate the voltage drop across the bulb. So we have to find out what is the voltage drop is happening across this bulb. Okay. So at first, we know what is voltage. Voltage, the basic form is dW divided by dQ. The change of energy with respect to change in charge. So you can say also like that, change of energy with respect to change in the charge. So if we know dW and dQ, we can find out the voltage of this bulb. So we have to find, we know what is W, it also can be said dW, and we have to find out dQ, and we all know dQ is equal to I into d of t. So all of the value is given in this example. I is 2 ampere and time is 10 second, and unit is ampere second, or we can say it as coulomb. Okay, the unit of charge is coulomb, that is 10 into 2, that is 20 coulomb. So from this equation we can write down on this dW is 2.3 into 10 to the power 3 joule, and dQ is 20 coulomb. So using calculator, we can find this 115 joule per coulomb, or unit of voltage is joule per coulomb or volt. Okay. So this is the example 1.4. This is mainly related to voltage. Okay, we are talking about voltage, and so this is the basic expression for voltage. V is equal to dW by dQ. With the change in charge, the energy is also changes. So the ratio of dW and dQ also termed as voltage. So this is the first example for this presentation, and now I hope you all understand. Now I am going to the next, and that is practice problem 1.4. So the question says to move charge Q from point A to point B requires minus 30 joule. So assume that we have 2 points. Okay, this is point A and point B. We have to move charge Q from point A to point B. We have to move the charge Q. Okay. and for moving this charge we need some energy. This energy is minus 30 joule. Find the voltage drop VAB. So we have to find similarly voltage drop VAB between this point A and B when the charge is 2 coulomb or charge is minus 6 coulomb. So how we can find the voltage? First of all, we know power. What is power? Power P is equal to dW divided by dt. Rate of change of energy is termed as power. It can be written as dW divided by dq into dq divided by dt. Is there any problem writing like this? If you this and this will be crossed and it will be in the original form. So it can be written as P is equal to V into I. Okay. So this is V, and this is I. Okay. So we have to find this voltage drop. Voltage drop is, we can write VAB for 2 coulomb. It will be dW divided by dq. So dW, the work done required or the energy required is given as minus 30 joule. So dW is minus 30 joule, and dq for first case dq is 2 coulomb. So it will be minus 15 joule per coulomb, or the unit of commonly known unit of voltage is volt, joule per coulomb or volt. Similarly, this A is done. Similarly for B, you can see here the charge is minus 6 coulomb. So similarly VAB we have to find out for 6 coulomb. Similarly the equation is dW divided by dq, and dW is minus 30 joule and charge is minus 6 coulomb. So it will be 5 joule per coulomb or 5 volt. So this is the voltage required to travel a charge Q from point A to point B. Okay, now move to the next problem, and this is the example 1.5. What example 1.5 says? Find the power delivered to an element at t is equal to 3 millisecond if the current entering its positive terminal is given here. This is the value of current. What we have to find? We have to find the power. We know power P is equal to P into I. Okay. So there are two cases. For one case, this voltage is applied, and for second case, this voltage is applied. So for first case, this voltage V is equal to 3 into I. Okay. So 3 into I. What is the value of I? I is 5 cos 60 by t. Okay. So the unit will be volt. So it will be 15 cos 60 pi t volt. So this is the voltage, but we have to find out the power. So we know P is equal to V into I. So voltage for the first case is 15 cos 60 pi t. So this is the voltage, and the current is 5 cos 60 pi t. So we have to multiply this. This is a very simple multiplication. 15 into 5, it will be 75. It will be cos square 60 pi t. This will be watt. Unit of this will be watt. So we have to find the power for 3 milliseconds. So time is equal to 3 millisecond. That means 3 into 10 to the power minus 3 second. Okay, now input the value of time in this power. P will be 75 cos square 60 into 180 into 3 into 10 to the power minus 3. So by using calculator you find 75 cos square and it will be 0.18 pi. It is 0.18 into 180. As this pi is inside this cosine function, so it will be not 3.1416, it will be 180. So using calculator you can find the value of power, that is 53.48 watt. Okay, you can use calculator. So now for the second case, this is B and here is the voltage. V is equal to 3 di divided by dt. So we have to differentiate the current to find the voltage, that is 3 d by dt. What is the value of current here? Current is 5 cos 60 pi t. Okay. So now we have to differentiate this. We all know the differentiation. So differentiating cos, it will be minus sine. Okay, and we have to differentiate this 60 pi t and it will also give us 60 pi. So this is the basic concept of differentiation. So first of all, this will be minus sine 60 pi t, and also we have 60 pi. By differentiating this, again 60 pi t. Okay, so multiplying this we can find, so this 5 is missing, so this will be 5 minus 5 sine 60 pi 2. This will be minus 900 pi sine 60 pi t, sine 60 pi t. So this is the voltage. Okay, so but we have to find power. Okay, so again we have to need V into I. So voltage is minus 900 pi sine 60 pi t, and what is the current? Current is given 5 cos 60 pi t, 5 cos 60 pi of t. So now we have to multiply this. Multiplying this, we find 9 and 5 multiplied by minus 4500 pi, and here will be sine 60 pi t into cos 60 pi t. So total unit will be watt, but we have to find this power at t is equal to 3 millisecond. So we have to put down the value of time. By putting the value of time 3 millisecond at here, t will be 3 millisecond and here will be the 3 millisecond. So we find minus 4500 sine 60 pi t, it will be 0.18 pi. It will be 0.18 pi. Similarly, it will be cos 0.18 pi. So using calculator we can find, so what should we use? We should 4500, this will be here will be the pi. So minus 4500 minus 4500 into 3.1416 into then sorry, here will be sine 0.18 pi, it will be 32.4 degree. Sine 32.4 degree into cos similarly 32.4 degree. Using calculator we get minus 6.396 kilowatt. You can check it out using your calculator. Hope you can do it by your calculator. So this is the problem or example 1.5. We have to find out the power. We have current and voltage is given. This is the very simple formula, P is equal to VI, but there are some arithmetic or differentiation type problem. Hope you can understand this very well. Okay, let's go to the next topic or next problem, that is practice problem 1.5. So this is very similar to example 1.5. Here we have to find the power. So element in example 1.5. So the data, that is current is same as example 1.5. The current was I is equal to 5 cos 60 pi t, 5 cos 60 pi t. So according to this question we have to use example 1.5. In example 1.5 the current is 5 cos 60 pi t and time here is given 5 millisecond. If the current remain the same but the voltage, current is same in the problem, but voltage, first step V is equal to 2I, and second step for second step V is this. So let's start step by step. For voltage V is equal to 2 into I. So it will be 2 into what is the current. Current I is equal to 5 cos 60 pi of t. So it will be 10 cos 60 pi of t. It will be voltage. The unit will be volt. Okay. Now we have to find power. P is equal to V into I. V 10 cos 60 pi t and current is 5 cos 60 pi t. So it will be, by multiplying, it will be 10 into 5 50 cos square 60 pi t. What will be the unit? It will be watt. Now we have to find this power for t is equal to 5 millisecond. Okay, so t is equal to 5 millisecond. This means 5 into 10 to the power minus 3 second. So power will be P is equal to 50 cos square 60 into 180 into 5 into 10 to the power minus 3. So we find 50 cos square, it will be 0.3 pi, that is 0.3 into 180. So using calculator you find the power is 17.27 watt. So this is the power for voltage V is equal to 2I at time 5 millisecond. Now for B section. So we have the voltage V is equal to 10 plus 5 0 to t. What is the value of t? 5 millisecond. So this is 0 to 5 millisecond. 5 into 10 to the minus 3. And what will be the current? Current is given as 5 cos 60 pi t. Okay, into dt. So we have to solve this. This is a simple integration. 10 plus 5 integrating cos, we will get plus sign, and by integrating this 60 pi to pi t, we will divide the whole thing by 60 pi. So what will happen, this 5 will go outside into 5, and this 60 pi here will 60 pi, and integrating cos we get plus sine 60 pi t. This is the positive sign, but here is multiplication. Okay, but there is a limit. Okay, the limit will be 5 into 10 to the power minus 3 to 0. Now calculating 10 plus 25 divided by 60 pi, it will be sine here will be sine 60 pi into 5 into 10 to the power minus 3 minus sine of 0, that will be 0. So use calculator. Okay, using calculator we get the voltage 10.107 volt. Now we calculate the voltage, but we have to calculate the power. P is equal to V into I. So voltage is 10.107 and I is 5 cos 60 pi t, already given in the question. So what is the value of t? Value of t is 5 millisecond. So it will be 10.107 into 5 into cos 60 pi into 5 into 10 to the power minus 3. Just use calculator to multiply this to obtain the value, and we obtain the value is 29.7 watt. Okay, so this is the answer for second section of this question, and the value of power is 29.7. So example 1. So in example 1.6, what is the question asked to us? How much energy does 100 watt electric bulb consumes in 2 hours? This is a very simple question. We already know that P is equal to dW by dt, and it can be rewritten as dW is equal to P dt, or W is equal to P into T. So we have to find out how much energy 100 watt electric bulb consumes in 2 hours. So the rating of bulb is 100 watt. This 100 watt bulb is connected to some sort of energy source for 2 hours. So what is the total value of the energy? So P is equal to 100 watt and T is equal to 2 hour. So it will be 200 watt hour. But if we want to find it in the unit of joule, then 1 watt hour is equal to 1 watt into hour means 3600 second. That is 3600 watt second. That is 3600 joule. Okay. So to find it in joule, so 1 watt hour will be 3600 joule. So this total unit, the total section unit will be joule. So it will be 720 kilojoule. So if there is electric bulb of 100 watt is connected for 2 hours, it will consume 720 kilojoule, and another watt it will consume 200 watt hour. So now in the next problem, that is practice problem 1.6. Practice problem 1.6 says that a stove element draws 15 ampere, okay, when connected to a 240 volt line. Suppose we have a stove element, that means we are using it for cooking, okay. So we use this symbol, and this is connected to an 240 volt line, and it takes 15 ampere, okay. How long does it take to consume 60 kilojoule? Okay. So this stove element have to consume 60 kilojoule, where the voltage is 240 volt and current is 15 ampere. So this is similar to this problem. We know P is equal to W into T, okay. So now W is equal to PT. There is slight mistake. W is equal to PT, not P is equal to WT. Extremely sorry. It will be W is equal to P into T, and P can be written as VI into T. We have to find T. T is equal to W divided by VI. So what is the value of W? How much energy the stove should absorb? This is 60 kilojoules. 60 into 10 to the power 3. Voltage is 240 and current is 15. So using calculator, the time will be 16.667 seconds. So in a 240 volt line, if a stove consumes 15 ampere, in 16.667 seconds, it will consume 60 kilojoule. Okay. Okay, now example 1.7. Before starting example 1.7, we have to know the direction of power or the sign of power. You can see here, and I can write the positive and negative. If the current entering the positive and exiting the negative, then power is positive. This is for this book. This is for this book, and you can take vice versa, opposite to it. But in this book, for all math, we will assume this: if current enters the positive terminal, then power is absorbed. And opposite to this, if current entering in negative terminal and exiting from positive terminal, so it will be supplying and power will be negative. Okay, so if current entering the positive terminal, power is absorbing. If current entering the negative terminal, power is supplying. So let's go back to our example 1.7. So in this example 1.7, we have to find the supplied power and absorbed power by each element in the figure of this 1.15. So first of all, give the direction of the current. So here you can see for P1, current is entering in the negative terminal. So as current is entering in the negative terminal, so what will happen? It will supply the power. So P1 will be the negative. P is equal to V into I. Voltage 20 volt and current is 5 ampere. That is minus 100 watt. So this 20 volt voltage source is supplying the power. This is power supplied. Okay, now for second, this P2, and this is some sorts of resistor or load. You can see this is a resistor. So this current 5 ampere entering the positive terminal. So if it enters positive terminal, that what will be the sign? Sign will be the positive. Voltage is 12 volt and current is 5 ampere. So this will be the positive 60 watt and this will be absorbed power. Then P3, similarly P3 you can see here, and this P3 current also entering 6 ampere current entering to the positive terminal. So plus 8 volt and current 6. This is 48 watt. This is absorbed. This is absorbed. And finally P4. For the P4, this is dependent current source. Okay, so for P4 you can see here it is a dependent current source and is supplying the current. Okay, this supplying the current, you can see in this direction it's supplying the current. So for supplying the current, what it will be? It will be, first of all, we know P4 is equal to V into I. So what will be the voltage? Voltage will be this. Okay, as these two branches are parallel, so voltage will be 8 volt. Okay, voltage will be the 8 volt and it is current source, that is it is supplying the current, that is minus 0.2 into I, 0.2 into I. What is the value of I? Value of I is given here, 5 ampere. So minus 8 into 0.2 into 5. So it will be minus 8 watt. So these are the this is minus 8 watt, that means this is supplying. Already from this figure we can know this is the passive current source, passive element, sorry, yes, this is dependent source, not sorry, this is dependent source, dependent current source. It's supplying the watt of 8 watt. So what will be the summation of power? The supply power and absorbed power must be equal. So P supplied will be minus 100 minus 8, this will be minus 108 watt, and P absorbed will be plus 60 plus 48 and this is also plus 108 watt. So using the conservation law, total is 0 watt. So the amount of power supplied is equal to amount of power absorbed, and this satisfied the law of conservation. Okay, so from this math we know the basics of power supplying and power absorbing. In the upcoming videos it will, if you don't know this, when the power is supplying or absorbing, it will be difficult to find out for complex circuits. So we will discuss it later in our later videos. Now another similar problem of example 1.7, that is practice problem 1.7. So this is the similar type of question. We have to compute the power absorbed or supplied by each component of the circuit of figure 1.16. So first this P1. First of all, this current entering from the negative terminal. So P1 will be minus 5 volt, and in this branch, what is the current? Current is 8 ampere. So it will be minus 40 watt. First of all, we have said we are taking minus sign as power supplier. This is supplied. Now second case P2, you can see here, although this is the voltage source, but current is entering in the positive terminal. So it will be P2 plus, what will be the voltage? What is the voltage? Voltage is 2 volt. Voltage is 2 volt and current is 8 ampere. This will be plus 16 watt. This is absorbed. This is absorbed. And for P3, you can see here, for P3 the direction of current entering to the positive. So for P3 it will be plus, what is the voltage? This branch and this branch are in parallel, so the voltage will be same. This branch having 3 volt, so this branch having also 3 volt. As in we know, in parallel the voltage is same, and in series the current is same. So voltage is equal to 3 volt and current is 0.6 into I, that is 3 into 0.6 into, what is the value of current? This is 3. Use this multiplication. Sorry, the value of current is not 3. The value of current is 5. You can see here, this is I and this I is here, so it will be 5. There will be the 9 watt. This is plus 9 watt. That means power absorbed. And finally P4. P4 is equal to, you can see here, current is entering the positive terminal. So this also will be the positive terminal. Voltage is 3 volt. Current entering 5 ampere. This is 15 watt. Similarly, power supplied. This is power absorbed. Power supplied is equal to minus 40 watt. Power absorbed is equal to 16 plus 9 plus 15 is equal to plus 40 watt. So what will be summation of this 0 watt? That is law of conservation is satisfied. This means the amount of power we supplied must be equal to absorbed power. This is the law of conservation of power, or law of conservation. Okay, thank you everyone. Hope you will understand all of the problem. If there is any problem, you can tell me in the comment section. Thank you everyone.